So, good morning, everyone, and welcome to our policy conference, Solar Energy, a Strategy Towards a Sustainable and Circular PV Industry. As the name suggests, we will be discussing various aspects, challenges, and legislative strategies to ensure a resilient and sustainable solar sector. And we are lucky to be joined by a panel of experts who have a wealth of knowledge on all different aspects of the industry, so it's going to be a good one. This policy conference was largely organized by an H2020 innovation action called Photorama. I'm a partner of Photorama. My name is Tess, and I'll be moderating. Photorama is focused on contributing to the circularity or to progressing circularity in the PV industry by developing new technologies, as well as different business models, policy recommendations for high-value recycling of PV panels. We're also joined by the coordinator of the project, Claire, who's going to be an expert in giving her input and insights from the project. So before we get started with the panel discussion, we want to get to know you, our audience, a bit more. So we have our first Slido question, our first Slido poll. If you could please take out your phone or computer or a device that connects to the internet, and you can either scan the QR code or type in slido.com and type in the code. And you should see a list with the name of the panel session coming up. Give everyone a minute to log on. So, who are you? Who are we speaking to today? All right, we've got a big representation from the business so far. Okay. Give it another couple of seconds. All right. Some researchers, some from interest organization and NGO. All right, but mainly from the business sector. Kind of surprising, but glad you guys are here and joining us today. So now that we got to know you guys a bit more, I guess it's only fair to get to know our panelists a bit better. So I would ask you to introduce yourself, say your name, your organization, and maybe one or two sentences about your relation to the topic. And we'll just start with Luca and then work our way down. Oh. So please.
Yes, so I am Lucas Weiss, and I am CEO of Voltec Solar. Voltec Solar is a French PV module manufacturer. We have a capacity that will reach this year 500 megawatts. It corresponds to around 1 million PV module put on the market every year. And we are working with Ecodesign strategy for several years now. We have calculated our first carbon footprint for PV module 12 years ago, and yes, we are working now extensively about the circularity and how to make our PV module more sustainable.
Great. David.
Thank you. Welcome also from my side. I'm David Moser. I'm head of the research group at Direct Research in Bolzano, Italy. I'm also the vice chair of the European Technology Innovation Platform for PV and the coordinator of a Horizon 2020 project called Trust PV, which I will have the chance to show a little bit more later on. So with these different hats, we'll look into the, let's say, topic of sustainability by looking at the impact of increasing performance, extending lifetime of PV modules and PV components, and how they positively affect the carbon footprints of PV systems in general.
Claire?
Good morning, everyone. From my side, so Claire Agrafey. I work at CINEA in France in the solar technology department as researcher, but also as a coordinator of European project. And yeah, I work on all topics that are related to photovoltaic sustainability. And I'm with a strong focus on the development of recycling technology. And this is one of the main topics, the technological development of recycling technology of our project Photorama, which is very much highlighted today.
David?
Thank you, and good morning from my side as well. I'm Davide Polverini. I work in the European Commission, Directorate-General Growth, on the implementation of the Ecodesign Directive and the energy labeling regulation. I'm responsible for a number of product groups, ranging, for instance, from smartphones. You may have heard that a few days ago the Commission adopted an eco-design measure and an energy labeling one on smartphones with a lot of circular economy aspects. But the main reason for me being here today is the fact that we are preparing potential eco-design and energy labeling measures for photovoltaic modules and inverters.
Good morning. My name is Tom Romans. I work for VITO, which is a Flemish research and technology organization. The main topic of the research in my unit is sustainable materials management for the circular economy. And today I'm going to talk about some lessons that we've learned in the Circusol project, which is a Horizon 2020 project, which finished last year at the end of the year. And for which I was the coordinator. And the topic of Circusol was circular business models for the PV industry.
My name is Pascal Leroy. I am the Director-General of the WEEE Forum. WEEE stands for Waste Electrical and Electronic Equipment. PV panels, photovoltaics is part of WEEE legislation in Europe, and that's one of the reasons why I'm here. And the WEEE Forum is an international association speaking for 50 producer responsibility organizations. They are entities mandated by producers to take back, to responsibly manage the collection and recycling of electrical and electronic waste.
All right, great. Thank you. Thanks for joining today. Before we go to our first question, I just want to give a small overview of what you can expect in today's session and maybe a bit of a reminder. So we have 3 main panel questions. 2 panelists will give an in-depth input to each question, and each panelist will then have 4 minutes for this in-depth input. The floor then opens up for about 7 to 8 minutes to all panelists for an open discussion. At the very end, we will end with just questions from the audience. But audience, to you, I want to say you have the opportunity throughout the entire panel session to submit your questions. We also reserve the right, or I reserve the right, to ask one of your questions in one of these open floor discussions. So I really look forward to hearing what you want to hear. Okay, let's get started. Before the question, we actually have another quiz questions for you guys. We want to test your knowledge a bit on PV recycling and the PV industry. So if you could grab your phone and log on again. And our first question is, can you name the critical and valuable metals that are not found in PV panels from the list given? It's not an easy one, so, or is it? I don't know. Give you guys a couple of minutes. All right. I see we have a majority who are saying none of these above. Some thinking beryllium, silver, silicon, indium, none for aluminum or cadmium. Okay, I guess we do have a couple of experts here because indeed all of those metals are found in PV panels in some form or another. Some in very small amounts, some in bigger amounts, but you can find all of these metals and more. So thanks for participating. And we have one more Slido question for you before we start the first question, the panel question, right? So with respect to different types of design and technologies, how many types of PV panels are in use or on the market today? Is it 100, 450, 65,000, or 105,000? Okay. So a nice diverse selection of answers so far. Yeah. Oh, maybe we're going to have someone take the... Oh, okay. All right. So our audience says it's a tie between 65,000 and 105,000. But indeed, it is 105,000. There are many, many, many types of PV panels on the market, which brings us to our first question. So as we've learned from our quiz, there is really a huge variety of PV panels that are all containing various amounts of critical raw materials and critical and valuable metals. These critical raw materials are necessary for many products in Europe, PV panels and beyond. Yet the EU still relies heavily on imports to get these materials. So one way to fully utilize these resources that are already in Europe is to take a circular economy approach, meaning we retrieve these materials used in old PV panels and recirculate them back into the market for further use. And this can already start at panel design, which brings me to my questions. So considering the variety of PV panels, how can circularity be incorporated in the design stage? And as a follow-up to this question, how might firms be incentivized to foster more sustainable manufacturing? And our experts giving input are Davide Polverini and Lucas Weiss. Davide, I give the floor to you. Can you hand him the... Yeah, great. Thank you. And your 4 minutes begins.
Thanks. Yes. Very briefly, because I have 4 minutes to reply to this question, plus I don't want to be boring, I will try to reply to, you are experts, as the test confirms. So no need to elaborate so much on the technical content, rather to, in reply to the issue that it is, let's say, kind of acknowledged. So how can we promote the circularity of photovoltaic modules that are on the market via regulatory proposals? Well, I want to just show what we are doing in the preparation for these eco-design and energy labeling requirements. I will not go into the details, but just to mention that we are, in general, working on typologies of requirements that are basically under 3 main categories. Requirements more under the realm of energy efficiency. You see here energy yields, efficiency of photovoltaic inverters, and a potential energy label for photovoltaic modules. We are working on a requirement for the carbon footprint of the manufacturing phase of photovoltaic modules, plus, and I'm coming to the question, we are working on a set of requirements on aspects related to circular economy and material efficiency. More in detail to requirements on the durability of the products. There are tests on these that we could use to the extent of showing compliance with the potential regulation, and requirements on aspects related to repairability and recyclability. More on recyclability for photovoltaic modules and more on the aspects of repairability for photovoltaic inverters, because it is known, understood in literature, that the inverter is typically the component to be refurbished more over time in a typical PV installation. Just to mention that there has been supporting work ongoing, but still there is and there will be. We have recently launched, together with the colleagues of the agencies, a call, and I see there are some experts today that maybe could even be interested, on developing a potential method to have a recyclability index for photovoltaic modules. And soon we will launch another call on standardized tests for long-term durability. So if interested, have a look and apply, because we are in search and need for this. I just close with this, that it is, a procedural slide, just to say that this is an ongoing process. under preparation. We are in a stage that we are in performing our internal analysis, but all going fine. Around October, we should come out with a draft proposal of these regulations, which will be out for comments to stakeholders. And when I say stakeholders, it's really everyone: companies, member states, institutions, users. And as I always say, if you have comments, please make your voice heard earlier than later. Don't come when the regulation is adopted, is published. We cannot do anything at that stage. So because for instance, and I mean that's useful, I have been in contact with some stakeholders from the real world, from industry, and we are checking, for instance, for the recyclability requirements, so about the information of which materials, on practical solutions on how to implement it, for instance, with a QR code to be put on the module. Whatever of feedback we receive, it can be useful and can be taken into account.
Okay, great, thank you. Yeah, and luckily we're also joined by someone from the industry to give their perspective. Luca?
Yes, thank you. So, as an industrialist, I want to give you a little bit my feedback about what we have been doing these last years and how do we see a little bit the future. And so as I said before, we have done our first CO2 calculation 12 years ago, and it was opportunist because on the French market we got some kind of premium if you have a low carbon footprint. So there was some incentivize to do a better carbon footprint. And then we started to ask how can we improve this carbon footprint. So we started to do some LCA, life cycle analysis. We worked on material, on energy consumption, and then we go to this eco-design strategy. And it's something important for me because from my perspective, the eco-design is not a note that you can give to a product, but a pathway. Once you are good in something, if you can reach a better efficiency, you will ask you, how can I do better? How can I incorporate more recycled material and so on? And any activity, any industrial activity has an impact. If we are doing something, we have an impact on our world, and it is important to see how we can reduce this impact. And you will never reach the right level, and it is always possible to do something better. And so from this perspective, I think that in an eco-design strategy, you have to criticize yourself quite a lot. And I think that we all agree that PV is one of the best energy source available today for the humankind. But actually, I don't consider that it is a sustainable technology, because all the PV products that we are producing today are quite difficult to recycle and to value at the end of the life. I mean, we have done a lot of effort. If you look at the PV module 10 years ago and today, we are consuming much less raw material, we are consuming much less energy in order to produce it. So the carbon footprint reduced a lot already, but it is still difficult to care about the end of the life of the PV module and the circularity. One of the points I would like to highlight regarding your question is the responsibility of the manufacturer. From my point of view, we should not have to incentivize the firms. I don't agree with your question. Actually, as an industrialist, I am responsible of the product that I put on the market, and I have to take care about the end of the life of the PV module. And this is why Voltec is also involved and committed in the action, in the initiative in France, in order to recycle the PV modules. And it is strange for me to see so much imported PV module and no one caring about what we will do with this future waste that we are putting on the market. And what I have learned, because we have talked about with our suppliers, and we ask them, okay, how can we put material coming from recycling into the material that we are buying? And I think that it is important, if you want to build a circularity, to put in contact the people caring about recycling and the raw material suppliers. And this is a work that we are doing today, and there is a very promising elements. We are talking about circularity on the glass, circularity on the aluminum. That's easy. Circularity on silicon, which is also something coming. So it is very promising, but I wonder if I would be exporting my PV module in Peru, in South America, how would I be able to care about the recycling? And it is a little bit what we are living today in Europe. We are importing a lot, and for me, it is not the responsibility of the recycling firms to take care about recycling, but the responsibility of the manufacturer.
Great, thank you. I have to say that's a very progressive business thought, but yeah, I appreciate it. So now we open the floor to our other panelists. Does anyone have some input they would like to give? Claire?
Yeah, I may have a question for Davide. The WEEE Directive is currently under evaluation, and they are saying that they are doing this evaluation aligned with the Ecodesign Directive, and I would like to know how does it work, and because they are talking about the ecodesign, the generic ecodesign, and I wanted to know how does it work for the PV ecodesign that is under implementation.
I suppose you refer to the upcoming Ecodesign for Sustainable Products Regulation. Yes, basically it is true. We have this work, which is in the framework of, this preparatory work is in the framework of the current Ecodesign Directive 2009-125. It is true that the directive is being possibly repealed, amended, to be seen, but a new eco-design, not anymore directive, but regulation is coming. When? Possibly next year, but to be seen for the exact timing. It will be the Eco-Design of Sustainable Products Regulation. To cut the long story short, the main two elements of novelty will be in much more extended scope in terms of products and a more extended scope in terms of requirements that we can propose. This said, we see again the products, photovoltaic modules and inverters, to be fully in the scope of the current Ecodesign Directive, and as such, we would aim to basically finalize the work within and before the SPR. It is also true that the typology of requirements that we are exploring, I was briefly mentioning energy efficiency, material efficiency, and carbon footprint, and I mean the approaches we are proposing, a new methodology for conformity assessment, are things that can certainly be an example, an illustration, information useful for ESPR. But again, we want to end this work within the current Ecodesign Directive, because obviously we don't want to lose this window of opportunity without having to wait for the finalization. Yeah.
Yeah, I just wanted also to ask, because and I'm happy to know about the update on the eco-design, but the WEEE Directive, they say that they are working on, a line, and I mean for the PV eco-design specifically, do you have any link with this evaluation on the WEEE Directive?
Thanks for this question, because this gives me the chance to indeed explain very briefly the fact that eco-design and energy labeling apply to products when they are placed on the market. when they are sold. And even for market surveillance, we can do checks until that moment. We don't have then direct legal control for the subsequent phases, the operations, in use, potential repairability, and end of life. Also because some of these phases are covered by other pieces of legislations, like the WEEE for the end of life. The two directives, the Ecodesign and WEEE, they talk each other because there are explicit links within the text, and surprisingly also the desk officers talk each other, so I'm in contact with my colleagues, and we typically ensure that with Ecodesign we give provisions that are, for instance, for recyclability, so on the capability, on the design features that allow the product to be recyclable, whereas the WEEE will then take more care of the, let's say, actual process of recycling. And the two things are obviously interconnected.
Great.
Thank you very much.
Yeah, thanks. David?
I have a question for Lucas. So you presented quite a progressive view from a module manufacturer point of view. Do you see a similar appetite from the customers for sustainable products? And even the possibility to pay a premium if the product is more sustainable?
Not really. Not really. Today, the market organization is still quite price oriented, and I think that if there is no regulation, it will be complicated to promote the circularity, because today it is, and especially when there is incentive for it, it is still less expensive to get new raw material than to recycle. It's a topic about also the cost of recycling, and today most of the material coming from recycling is more expensive than new material. There is maybe the exception of the glass, where the recycled glass may help to reduce the energy consumption in oven, but otherwise most of the and especially for example for aluminium, new aluminium is today less expensive than recycled one.
Yeah, that's a great point. Pascal, would you like to say something?
Yes, I'm a bit confused why some of the panelists call this a progressive attitude, because the principle of manufacturers taking back their products is embedded in the extended producer responsibility legislation, which has been around for more than 20 years. And so it has nothing to do with conservative progressive, it's producer responsibility. And of course, I fully agree, you have to have the financing in place. So whether you do that with a pay-as-you-go or another system, that's absolutely crucial, because the products have a 20, 25, 30 years lifespan. And so the financing has to be there by the time they come back as end of life. And that's absolutely crucial. They are not just 1 or 2 year products. And but I think the system in France is quite well developed with your visible fee. So you have some kind of guarantee system when it comes to financing. And I think it should be a model for the rest of Europe.
No, great, thank you. I guess we can move on to our next question now, if no one has anything else to say. Perfect. So we actually have another question for you guys, our audience. Oh, sorry, I should have told you that you were going to be tested on your knowledge today. We have our Slido for question, if you could bring it up. Thank you. What is the average lifetime of a PV panel, according to your expertise? I'll give you a couple of seconds to fill it out. It may have already slightly been mentioned just a few minutes ago. I hear we have some good listeners, so at least something. Give it just a couple more seconds. All right. We have a very knowledgeable audience today. I'm impressed. So indeed, the average lifetime of a PV panel is currently 30 years. or well, more or less 30 years on average. But depending on the use and purpose of the PV panels, such as industrial versus residential, this lifespan actually ranges from 10 to 40 years. So this brings me to my next question, panelists, on Tom and David. So what are some strategies and other approaches for extending the lifetime of PV panels, especially those that are only in use for 10 years? Maybe building off of the directive, Ecodesign Directive we heard about earlier.
So thank you very much for the question. I will also use some slides, which gives me the opportunity to also show you what is the philosophy and the background of the Horizon 2020 project called Trust PV, and the role that we are playing in terms of sustainability. So from my perspective, from our perspective, what needs to happen is that we need to look over the whole value chain. So we need to break silos, people, various stakeholders, they need to talk to each other and try to solve each other's issues. Because the earlier you mitigate a problem, the less costly it will be. So what let's say the approach of Trust PV and how those approaches they can work in terms of extending lifetime or having a more sustainable, let's say, business model is to start from the design of a PV plant and how you can improve the producibility assessment, the yield assessment. So how can you make sure that in your business model you have a more accurate prediction of how much electricity your system will produce. And then you go along the whole value chain looking at, let's say, better procurement. So how can I procure high quality products to make sure that those products, they have an extended lifetime? And then operation and maintenance. So how can I develop diagnostic tools that can help in finding failure more quickly, or in considering and following the health status of your components in a PV systems. But essentially what we're trying to do here is that there is always a lot of focus on capacity, on gigawatts installed, which is great to see these records being beaten on an annual basis. But what we ultimately need to look at is to reliably and sustainably generate terawatt hours. So it's not just about capacity, it's about generating electricity for an extended lifetime. And this should have been an animation, sorry about that, but the plot behind is the impact of anything related to reliability and extended lifetime on the levelized cost of electricity. You cannot see, but pretend that you can see the plot in the background. So on the right-hand side, without going too much into technicalities, you have essentially the levelized cost of electricity that you would have if your plant lasts for 20 years. If you have high degradation of your component, if you have high operation and maintenance cost. On the left-hand side, the histogram becomes 50% less. If you extend the lifetime to 30 years, you have lower degradation and you have lower operation and maintenance cost. What does he have to do this with sustainability? Because essentially by extending the lifetime, and this is the plot that you can actually see, extending the lifetime and reducing the degradation, you can see how the red curve will have a lower carbon footprint in terms of grams of CO2 per kilowatt hour. And you can almost half the carbon footprint if you go from 30 years to 40 years and you reduce the degradation from 0.7% per year down to 0.3. So this is just to show the importance of anything related to performance and reliability. In Trust PV, we also look specifically into the topic of what is called continuous or progressive repowering, meaning that there is a repowering wave at the moment in Europe, and this will cause some issues because the standard, let's say, the default strategy is for these for the PV components and PV modules to, in the best case scenario, to be treated as waste. But we need to make sure that some of these modules can actually be reused if they are still healthy, let's say. And in Trust PV, thanks to the work from the partners BioRE and IMEC, They are looking into how this can be done also through regulations, through IEC standards, because any single test that you do to check how healthy a PV module is, you will have a cost. And this cost might be actually higher than buying a new module. So we have to look into this delicate balance, and those are the key activities done in the project Trust PV.
Okay, great. Thank you. Passing it down.
Okay, thank you, David. So you talked about reliability of an installation if you look over a period of 30 years, and indeed it's important to have an installation which is reliable, because in that way you can reduce the carbon footprint of the electricity produced. I can add to this that we looked into scenarios where you have an installation that you keep for 30 years, like the one you have, and you compare that to scenarios where you would replace the PV modules after 10 years, so every 10 years, that means 2 times in a lifetime of 30 years, or at the half of the lifetime, so after 15 years. And then we did a life cycle analysis also to look into carbon footprint here. The graph is about just the general environmental impact. But you have similar graphs if you look into greenhouse gas emissions, or if you would look into other parameters like acidification and so on and so on. But the main lesson here is that it's always a good idea to keep installations alive as long as possible. And what is more, you will never offset the additional impact that you generate by replacing an installation by more efficient ones, and even PV panels of a more recent date that are produced in these manufacturing installations which have a lower emission rate. So you will never offset the additional environmental impact of these more efficient PV modules. So keeping just the same installation alive for a longer period is always a good idea from the environmental perspective. That's clear. There's no discussion about that. On the right-hand side, then you have the business case or the economics of keeping installations longer alive. And there we looked into what you also already mentioned, repair. Sometimes you need some repair, you have to replace some of the components of an installation. And there you see, as you already mentioned, that especially for the older panels, if you have panels which are like more than 10, 15 years old, it isn't really worth to do the investment to repair the installations to keep installations alive for a longer period. So there today, we still have a problem, and that's one of the conclusions of our Circusol project. So what we have learned is that the initial idea that we had within Circusol, that we could maybe find some ways to really scale up second life use for PV panels in Europe. For example, in the residential sector, we have this naive idea, but that people would maybe be interested to have second life panels on their roof instead of new panels. Well, that idea is a bit too simplistic. That's one conclusion. So we will not, in the short term, have larger installations put on roofs made of second life panels, even though it's technically feasible and it's environmentally speaking a good idea. So scaling up today is difficult because the business case is just not very favorable. On the other hand, and that's an important message that I want to bring here, you should not discard the idea of second life use, because there are some market segments and it might be some niche applications, but even then it's nice to try to give these panels a second life. You have niche applications, charging installations for e-steps and e-bikes, charging installations on events or festivals. You have the small installations, which you can find nowadays somewhere on balconies, for example. You have agro photovoltaics, where panels are not only used to generate electricity, but they have another function to protect the crops in the fields. So there it doesn't really matter whether these panels are the most efficient ones, and you can use older ones as long as they are safe and working. And there's some other market segments where it could be possible. So that's the message. Environmentally speaking, good idea. Business case today a bit difficult, but there are some market segments where it is possible, and we should not forget about the inner cycles of the circular economy, repair, reuse. We should not forget about that.
Okay, great, thank you. I have some follow-up questions for both you, David, and you, Tom. First, I direct it to you, David. So you explained that durability means less CO2 emissions, especially over time, or the longer the PV panels are used. But my question is, what is the effect of on the material needs of PV panels when you make them more durable? Is this requiring more metals, less metals? Like, how can we look at the sustainability of the materials used?
So the trend in the industry is there is a clear driver towards a lower carbon footprint, that we are using less materials. And that, of course, there is a continuous industry demand if this goes maybe towards a lower durability, because if you decrease the thickness of the cells and so on, they might crack more easily. So there is, of course, when you go in the direction of reducing the amount of materials, you always need to keep in mind that that product needs to work for an extended period of time. But if you look at the warranty given by the manufacturer, the trend is clear. Even if there is a reduction in materials, the modules are becoming more and more reliable, at least from a warranty point of view. The ITR PV, they published their own roadmap a few days ago, and they which is the way it works. They ask business and industry the way they see the evolution of some topics, let's say in the up to 2030. And by 2030, the idea is that PV module manufacturer, they will give a 40 years warranty in terms of production. And in terms of product warranty is more than 10 years. Now I'm asking which other industry is giving a more than 10 years product warranty. That's also something that maybe we should discuss. So there are various, the question that comes into my mind, the answer comes into my mind is the holy grail is, how can I make sure in a day that your changes in your PV modules do not affect negatively the durability? There is no answer for that. You need extended testing. You always need to develop new type of testing, because there might be some new degradation modes that we were not aware about it, and they might become evident only when we put the PV modules in the field. So it's extremely tricky. So even everything that has been developed by the IEC, all those standards, they give an indication, but they don't tell us for how long the PV modules will last in the field. So there is a whole innovation and a continuous industry demand on reducing the time it takes to give answers, and at the same time to introduce new type of testing and combining indoor and outdoor testing to make sure that whatever changes we have applied to the PV modules, they didn't affect negatively the durability.
Okay, great. Thanks for that. Yeah, it's a complicated road to navigate.
Yeah.
Did anyone want to follow up on this answer? Yeah, Davide?
Yes, a follow-up question, because just to have your view, I'm aware that for the durability tests carried out according to the 61215, actually there is, and it's under, let's say, revision, a so-called retesting standard. So there are procedures according to, I don't know, I'm changing in my product model only the backsheet, only some components. Okay, you don't have to go through the whole testing, but there are only some parts of the testing. Don't you see this as a kind of as an avenue to, let's say, tackle this aspect, which is important, how to be sure that incremental modifications do not affect the durability of the product?
Yeah, every time you change the bill of materials, you need to go through the standards, so you don't have to repeat everything, but depending on what you change in your bill of materials, you need to do some retesting. The issue is, what happens if I don't just change a little bit of the bill of materials, but introduce a new technology, for example? And so that is when we find new degradation modes, they don't come out from ISC testing yet, and so the ISC testing needs to be, let's say, changed and updated to make sure that we can also test for that. So without getting too much into technical terms, but consider that we got business here as well. We had in the past the potential induced degradation. No one knew what it was, and then it came out in the field. And now we have other light-induced degradation or light and temperature-induced degradation. So you have all this new technology there. You follow the IC standards. They go through they pass the durability testing, but in the field, then we see some surprises. So, and to make sure that the loop is shortened is quite complicated, because of course you cannot wait years and years to wait for these new degradation modes to happen.
Okay, thank you. Tom, I have a follow-up question for you. And so you gave the strategy of reusing panels and refurbishing them as a way of extending their life. And you gave these, you kind of said in some ways it's not such a great, or the customers are not so interested in using these panels, especially en masse. But on the other hand, there are a little bit of niche markets popping up for people who are interested in getting secondhand PV panels. So my question is, can you explain a bit the difference between, the business case for why secondhand PV panels are not yet favorable at the moment, and what are your insights into what is needed to develop this market for PV panels?
First of all, what we concluded already after 1 or 2 years was that the second-hand market for PV panels in Europe, it's simply not there. I mean, it's not developed at all yet. So we came a bit too early with the idea, we think, simply because all these installations are out in the field, and everyone is waiting for the big mass of PV waste that will come at one point, but it's not there. If you ask the recyclers, they will just confirm. So the large volumes are not there. So that influences the price, of course, and also the fact that testing for reuse already also incurs a cost. So it's quite expensive nowadays to procure large volumes of PV panels, which are good for reuse and which are tested and certified. So that's one thing. And the price is not very favorable. And then, people, they just don't trust them. And that's also related to the fact that there's not really a framework or a mechanism of certification when you would have a clear stamp, it's Second Life, but it has been tested and you have the guarantee that it will work for another 20 years. That's another case. But also that system is not there yet. So people don't really trust. We did quite some surveys in different segments in the population. And what you see is that, the Second Life is not an option for most of the people, especially for those people that are really investing into solar PV and large utility scale installations. People in the residential sector putting PV panels on their own roof. They just want the most efficient installation, and they want value for their money. On the other hand, there are some segments where a product as a service system could work, where people don't own the installation, but where they just buy the electricity. And then you have an installer putting the installation on the roof and just making an agreement with the customer, and they sell the electricity. And in that case, if the installer just trusts the installation and he has part of it a Second Life, but he knows it will work, then the risk is for him, and people could buy this electricity. In that case, that's not a problem. And then, of course, the large, the niche applications that I mentioned, those are applications where, for instance, area isn't that crucial. If you have a farmer in the south of Germany, he has a stable. He needs some electricity just to charge some of his appliances on his farm. Then he's maybe interested in a Second Life. installation or a couple of second life panels, just for his own sake, as long as the price is of course again a bit lower. So it's really looking for the sweet spots in the market, and looking for the right business cases. And it's not the simple idea of just replacing new panels with second life and just like that it will work. That's just not the case today, and that's what I want to stress. But in the future, of course, if large volumes are becoming available, things could change. Yeah. And if testing procedures are better and more efficient, could be automized in the ideal world, then we could get there at some point.
Okay, great, thank you. Maybe we can hear from a producer themselves, from the business person, on this new potential business opportunity of refurbishing PV panels and selling them. Has your company already looked into this idea? Have you had thoughts on investigating this market?
Yeah, before to talk about this initiative, I just want to share my thoughts about this market, because we can see today already the competition with the new coming pricing and efficiency of the new generation of PV module, and I think that it is maybe difficult today to value the second-hand PV module, because it has a cost to make testing and so on. But I actually think that it could be more difficult tomorrow, because the PV module price will still going down, and efficiency will goes up. So the competition maybe between new PV module and second-hand will be harder. And I was thinking about the industrial waste that I have in the company. For example, wood waste or the aluminum waste when I am producing. Actually, sometimes, depending on the market situation, I receive money for my waste because aluminium has a value, and sometimes I have to pay for the people to take my waste. And actually, I believe that in the PV module second-hand market today, if you throw your PV module, actually you should pay to help just the transport, the testing, and so on. Because otherwise you may not be competitive. I think that there is really a topic of a market organization, and I actually think that it will be harder tomorrow than it is today. So it's for me really a topic. And regarding the second life, I think that there is a technical topic for measuring the PV module, but I don't believe that it might be so difficult, because we know a lot about testing the PV module, we know about polymers, soldering efficiency, and so on. And I think that we will find a way to make kind of certification and to say, okay, this PV module can be used safely, but it might be difficult to ensure behind. And I don't see the residential market or any market related to a building where the insurance is a topic as a possible market. I think that a new market should open like the one which were presented. Yeah.
Thank you. And it's good you bring up the topic of waste, because this is very relevant in the coming years from PV. And this brings us to our next Slido question. So audience, please grab your phones. It's the last quiz question, I promise. Yes. So we want to hear from you. How much PV waste is expected in the EU until 2050? If you could give your best answer here. Well, I see everyone going for the high answer, maybe based on the past questions, so it's a good strategy. All right, give it just a couple more seconds. All right, indeed. Again, audience, you got it right. It's 10 million tons. I'm impressed. Yes, so we can expect 10 million tons of waste, of PV waste by 2050 in Europe, which is quite a lot to deal with. Yeah, and as you mentioned, yeah, dealing with this later instead of now is maybe a problem. So now we turn to Claire and Pascal to give some insights on how to manage some PV waste. And here's my question. When it comes to legislation, PV waste management is only regulated under the WEEE Directive currently, which is also under review, as Claire mentioned. So what are some of the critical issues with regards to PV panel waste management? And following this, how could they be addressed through legislation, for example, the WEEE or other legislation? All right, Claire, I give you the floor.
Okay, yeah, no, that was interesting. Oh, sorry. Thank you. Yeah. Okay, no, that was very interesting. The answer to the quiz. People thought there were more waste. 10 million is quite a lot already, but this is because there is so much deployment coming with solar energy that is announced in Europe and over the world. It means that people think that, okay, this is going to become a waste. We are not there yet, but this is what urged the question, because solar energy has to be sustainable. Okay, we know that solar energy will lead the energy transition, and in that sense, we have to think this globally. And we've talked quickly on the fact that we are dominated by Asian market. That's true. But the wastes, they are going to be on the ground in Europe, and we will have to deal with it. This is not the same question, and this is not an option. This is another kind of market. And when we are talking about waste, we are also talking about local markets. This is less than a global market when we are talking about product. So this is a very different issue. This is a very different perspective compared to the PV industry where we are talking about product. But the question has to come now because the waste, we've heard this last decade that the wastes are not here yet. That's true and not completely true. It really depends on the member states, and we also don't know if it's a problem of reporting, if it's a real lack of PV waste, or if also it's a problem of collection. I mean, there is many things that we can think the reason why we don't reach the collection target. So I will say a word on the legislative aspect. You may know that the WEEE Directive is the one that PV waste is under. This is under the category 4. This is not a specific category, which is a kind of consideration for the evaluation. The WEEE Directive. Another thing before enter specifically and deeply on the PV waste category and the consideration that we have to take is, I just wanted to mention that in Europe, we are the only one to make the recycling and the recovery, the waste management, so the collection, the recycling and the recovery of PV waste mandatory. So, and this is since 2012, and this is a huge progress because elsewhere in the world, this is not mandatory. So it means that it's end up in landfill or illegal shipment or whatever, but not good handling. So I just want to mention that we are a precursor in Europe, and that's good. That's a very good thing. This is my first point, because we have to keep progressing, but we are already in a good place to give example to the rest of the world. Now, PV waste and PV device at first is a very complex devices. So the WEEE directive needs more specification that is allocated to this category. So first, I won't talk about the collection, because I think you know more on this topic, but there is things to rethink on the collection stage, and we are working in the Photorama project also on methodology for further standardization that we will need for waste management, so after the collection we have the recycling, we have the treatment, so we have the recycling and the recovery of the secondary raw material. So this is a very important point, and this is kind of the reason of our project, because again, that's great in Europe. We recycle PV waste mostly, but the current practices are more oriented downcycling, meaning that we don't recover all the critical and valuable material that are embedded in the PV devices. In my slide, you can see that the composition in the PV device, we all know that the glass sheet is most of the weight. And we have the aluminium for sure. Lucas mentioned it. This is like a part of the revenue, an important part. We have the polymer, so a big issue here also, because plastic recycling is quite complicated, and this is difficult to integrate in the business case. And the metals, and this is where I come back to the WEEE directive, for which the recycling and the recovery targets are 80% and 85% of the mass. So it means that you see, you don't have to recover the metals. That's the fact. So if you recover the glass, the aluminium, you're good. This is a problem because, I mean, we are talking about million tons of PV waste. And again, I would say that those practice, this is based on shredding process. This is better than nothing, for sure. This is better than landfilling. This is better than, sending up, in emerging countries. Okay, that's something. We are progressing, and today with our project we try to progress and to improve and to move forward to upcycling. We are working on technologies that allow to recover those metals. And just to give you an example, because it looks like there is not much metals in PV device, but this is not true. I gave the example, okay, we have 4 to 5 metals in a PV device compared to a mobile phone where you have up to 50 metals. But this is because this is a much simpler device. But if you think about the number of mobile phone and the number of PV device, we are quite the same. So it means that we have the same volume, actually, of valuable metals. And I wanted to give an example. In France, for example, in 2021, Soren did collect something like 5,000 tons of PV waste. So we are at the beginning. So on 5,000 tons. So if you don't recover the silver, you lose 4 tons of silver, and you lose 210 tons of silicon. That's not nothing, and I'm talking only about 5,000 tons. And we just presented and we said that, okay, we will have millions of tons. So this is my point. This is very important, and this is very important that during the evaluation of the WEEE directive, they reconsider the recycling and the recovery target to be adapted to the PV waste. Because if they don't, this is not going to be mandatory, and we are going to have to lose, and more I would say, more importantly, this is something that we will lose indefinitely. This is an irreversible loss. So this is why this is very important that we should, at the legislative level, support this incentive and to promote downcycling. And yeah, I will stop here at this, and I will, Pascal.
Yeah, great, thank you. It's very informative. Pascal, do you mind?
Thank you very much. Actually, my slides are not technical content compared to the previous slides, but this is actually the membership of the WEEE Forum. As you can see, waste electrical and electronic equipment is a global issue. It's not just global, it's also a societal challenge. And that's what we need to keep in mind first and foremost. You put the figure of 10 million tons for Europe, but by 2050 it's going to be 78 million tons of photovoltaics that become waste by the year 2050 cumulatively. And so we as WEEE Forum, as an international association of producer responsibility organizations, we take on this challenge through different means, for example, research, partnerships, campaigns, and so forth. And collectively we have, or let's say in the past 20 years, we have collected approximately 35 million tons of electrical waste. But now to respond to your question, I think that from a societal perspective, the critical raw materials is the issue of greatest concern today. And that's also the reason why we have now a proposal for a CRM regulation that was issued a couple of months ago. And it is the issue of greatest concern because some of a country like China is dominating the entire value chain. Yesterday, someone from the Joint Research Center underlined that Europe has not more the market share than 7% in each segment of that value chain. So we are totally dependent on the rest of the world. So we urgently need to, let's say, put in practice strategies to have access to our own critical raw materials, for example, through recycling, but it could also be through agreements with third countries. And so for me, that's, and as Claire says, the recycling targets in WEEE legislation are mass-oriented. So there's no incentive for anyone to recover tellurium and gallium and all the other critical metals that were listed in your quiz. Absolutely no incentive. Fortunately, the CRM Act responds to this thing by saying that products in the future should have recycled content. By 2030, we should 15% of the demand for critical raw materials should come from recycling. 15%. By the year 2030. So the Commission doesn't call it a target, but it's a benchmark. And so, but still, this remains extremely challenging. The recycling rate for rare earth elements today is 1%, 2%, in some cases 5%. And so, personally, I don't see how we will get to the 15% by the year 2030. That's number one. So the critical raw materials for me is an issue of great concern. Another more practical issue, but not less relevant, is that is a collection target. So the current collection target says that of the volume of products you placed on the market in the 3 preceding years. So in our case, in the year 2020, 2021, and 2022, you have to collect 65%. And you show the figures of the lifetime, it's 30%, some people say 22%, but whatever life cycle or lifetime you define, it's not 3 years. So it's impossible to reach the 65% target. And this is something that the legislator should acknowledge. Because that's number one. And actually, it's not reachable for many other reasons for all the other products as well. But let's now just stick to the photovoltaics because it is simply not possible. And the thing is that it's part of, as Claire said, of category 4 in the WEEE Directive, meaning it's clustered with large equipment. But and what some member states have done, Poland, to name that member state, they issued a penalty to manufacturers, to producers, because they failed to reach the collection target for category 4. But it's impossible to reach that target because it's not just large equipment, for which it could maybe be possible, but it's also containing the photovoltaics in category 4. So it is totally not under the control of producers to reach that target, and nevertheless they have a penalty. And that's the situation in Poland, and that was a big crisis very recently that we were trying to deal with. I myself was giving a testimonial in a court in Malta, because they applied the same thinking that, okay, the collection target is 65%, and you, producer responsibility organization or producers community in Malta, you have not reached that target, therefore we issue a penalty. And there are multiple other examples throughout the European Union, and it's absolutely, in my opinion, not legally correct. And one of the reasons, I think, is because it's a directive rather than a regulation, which brings me to another topic, which is the classification. Recyclers want to know what is the volume. I mean, you showed 105,000 types of photovoltaics or panels. Recycler needs to know what type of panels are coming back and in what quantity and in what time scale. Now, the thing is that in the WEEE legislation, the statistics is quite poor. So some member states, they classify photovoltaics as hazardous. Other member states classify them as non-hazardous. Some classify them as a subcategory of category 4. So you have a patchwork quilt of regulations, and the statistics are not comparable. And therefore, the market is not going to work well, to function efficiently in that situation. And therefore, I think classification is also an issue of great concern. These are just a few. Financing I already mentioned. I think that's absolutely something that we should all be mindful of, because I mean, the products have a lifetime of 30 years, so they will at some point in time come back as end-of-life panels, and there will in all likelihood be a net cost, because there's always the logistics. You always have to collect them, even if the materials are a positive value stream, or the treatment in some cases, as Luca was pointing out, some of his waste in the process, in the manufacturing, is valuable, but still in the collection you will always have the logistics cost, which will also become more and more costly due to the fact that travel and logistics is expensive. So we need to have financing that is earmarked to pay for that cost in the future. And it's not just going to be next year or in 2 years' time. It's going to be in 30 years' time because of the life cycle, the lifetime of photovoltaic. So this is an issue of great concern that we need to be mindful of. If I have time, I could also mention the standards. Someone mentioned that the standards and referred to the standards. I think it's absolutely important that standards are legally binding, because now it's just a voluntary CINEA standard. Which is fair enough, but we need to make sure that the playing field is level, so that there's no incentive for some people to act irresponsibly and to dodge the system or to not meet the standards because they are voluntary. So we have to make these standards legally binding. It's a campaign that the WEEE Forum has been running for 10, 15 years. For some reason, the Commission does not acknowledge this point, and we struggle to understand why, because also producers are saying exactly the same thing, and recyclers as well. So if we want to create a level playing field in Europe, these standards or normative requirements need to become legally binding and enforceable.
Yeah, great. Thank you for your input. And this is a good point about legally binding, because as we know, the status of collection also varies a lot from member state to member state, right? Like France is quite ahead in terms of collection and waste management processes, where many other member states, as Claire also mentioned, there's no data, there's no regulation, there's no oversight on what happens, so we actually don't really know and can only assume that most panels are being downcycled. Great. Did anyone have... yeah, Claire, would you like to answer?
Just the answer to, I mean, just a comment on the standardization. I think this is a very, very, very important point, because we were talking about targets, recycling and recovery targets, but how do you assess that? There is no standards. So, you know, each recycler can make his own process methodology, and this is missing. And this is very important that, we are all equal in between member states, and this is where we need standardization, but not just only for that, but this is just an example to showcase that this is needed. Else, this is just reporting data that may not be reliable.
Yeah, great. Thank you. I have one question on this topic of waste and kind of combining the topic of eco-design and waste. So there's a bit of a contradiction. We heard from a scientist a while ago who's doing experiments at a university in Australia, and she mentioned they're doing experiments on extraction of critical raw metals of some of the newer panels that have a much lower amount of silver in the panels. She said that the processes that they're using, they're no longer able to extract silver from the panel because it is at such a low amount. And I see a contradiction here, because on the one hand, maybe on the face of it, a panel with less critical raw materials is great. It's good. It's less materials used. But on the other hand, if we want to encourage this sort of waste management, if we want to encourage more upcycling of panels and recirculation of these metals into the market, especially when there's no legislation requiring it, and companies need a profit, like it needs to be profitable for companies to want to invest in this sort of thing. How can we kind of navigate these types of challenges? How can we overcome this kind of contradiction when we see maybe eco-design and waste management? Can I open the floor? Yeah, please.
Yes, from my point of view, there is we have to prioritize this topic, and reducing the consumption is more important or come before recycling. So there is for me no contradiction or paradox. If you are able to use less product in order to build a PV module, you have to use less, and okay, it will be a topic for recyclability, waste management. It will be less profitable. But in terms of priority, you first have to reduce before to recycle.
Reduce before recycle.
And just to mention, okay, there will be less silver, but I come back to my 5,000 tons. Okay, we have 4 tons of silver completely lost, and if we have less silver, we will have 2.5 tons. I mean, this is still worth it to recycle those 2.5 tons. I mean, this is just, a comment on that.
Yeah.
I think this is still worth to...
Yeah. I guess when you look at it at an industrial level versus on a single panel level, the numbers change quite a lot, so.
Yeah, and this will be challenging for recycling, but I think we still should do it.
Yeah. Same. If anyone has anything else to say on the WEEE legislation or comment on this, then we can turn to our audience questions, who have been submitting questions the whole time. Maybe we just go down the row. So we have a first one. How can we promote the use of secondary raw materials in PV modules, especially for critical raw materials, to make the EU resilient for a supply crisis? This is open to everyone, but maybe Davide or David, would you like to give your input on this?
What I can perhaps say regarding related to the preparatory work for the eco-design measures is that we found, and we are trying to have a legally sound way to properly factor in within the carbon footprint calculation methodology the fact, if it happens, that someone may use recycled materials. I open a parenthesis. Nevertheless, I understand, and I'm happy in case to get anything, any different feedback, that these are, let's say, today, possibilities for the more classical materials, such as, for instance, as it was mentioned, aluminum, glass, but it is still to come for silicon. But in any case, we are setting the methodology in a way that this could be factored in, meaning the possibility to declare the use of recycled material that would certainly contribute to decrease the carbon footprint. But then this brings another problem. How do you check this? How do you certify? How you can attest in a reliable and verifiable way that you are not just cheating? I'm sorry, but to be clear, because what we want obviously to avoid is that this becomes in a regulation the point where you can shop for a better value, just declare some recycled material. So whatever, it entails technicals as well as legal problems about the assessment of the conformity.
Mm-hmm. Okay, thank you. Anyone else? All right, to our next question. This one is directed to you, Tom. You mentioned PV installations as a service. Are there examples of such practices at the moment?
Yes, of course there are. I think there's many examples. For instance, in the residential sector, you have installers not selling the PV, but selling the electricity as a service, and making a purchase agreement with the client, putting the installation on the roof. Might be some kind of a leasing contract or something else. There's multiple systems, and for some segments of the market it works. And we even had within Circusol one demonstrator where we had a truck stop with a large PV installation on the roof, where the electricity was sold as a service, and where we even also installed a Second Life stationary battery at the same site, and where then the installer, which was the owner of the installation, could balance the whole system and make it profitable for himself, and also attractive for the customer. So there's examples, of course. Yeah.
Okay, great, interesting. Do you maybe from your project have any reports or something where people can go look at this?
Yeah, well, everything is on the website. So as I said in the introduction, Circusol ended in December last year, and so all the deliverables which are public, because part of it is not public, unfortunately, you can find them on the website. So www.circusol.eu, and you can find everything. And the slides I have shown with the graphs. They are published in an IEA report, so if you go to the website of IEA, you'll find more information on the extension of the lifetime and the environmental impact.
Okay, thank you. To our next question, how to promote a new technology on redesign of PV that could reduce the future PV bill and carbon footprint? Will there be any policy to support recyclable renewable energy? I guess we heard a bit about the WEEE Directive, as well as the Ecodesign Directive. Would you like to comment any more?
I can speak, so like I was saying in the previous reply, just to integrate that for the requirements that we are working on the carbon footprint and linking to this question, what we found is that in quantitative terms, the carbon footprint of the manufacturing phase, bearing in mind that it's a carbon footprint normalized per the yield, so per how much energy is produced by the module, is typically affected by 3 factors. And that these are the ways where potential policy could have influence. The first one is the module yield. So obviously, if we normalize it per the yield, the higher the yield, the more beneficial will be for the carbon footprint. Then we have the quantity of silicon, of raw material used. And the third one is the carbon intensity of the energy used in the manufacturing phase. So obviously, these are three parameters playing with which manufacturers could then obtain a more favorable value of the carbon footprints. Mm-hmm. We are still, let's say, in the decision-making process for deciding whether this requirement will be an information requirement, so a compulsory reporting information requirement, or possibly a quantitative one, meaning a potential maximum threshold, for instance, of carbon footprint for the manufacturing phase of modules to be placed in the EU market.
Mm-hmm. Great, thank you. David?
One side comment. From, let's say, a not so close to market point of view, like research and development needs. So sometimes we have a dilemma in emerging technologies because the driver is high efficiency, maybe not so sustainable, or very sustainable but with not such a high efficiency in terms of cells and modules. So I think it would be important also to promote initiatives that the driver is not necessarily to reach a record efficiency for PV cells and emerging technology, but record sustainability KPIs for that specific technology. And this is a suggestion for people in the audience who are, for example, funding R&D projects in Europe, because typically in the calls we are looking, and it's good to aim at high efficiency, but I think it's important also to have specific call for funding in finding the champion in sustainability, let's say.
Okay, great. Then maybe we jump to one of the newest questions, because I think this tacks on very well. What are some of the technical challenges that PV recycling and material recovery have? So I guess more focused on the sustainability aspect, and what technological gaps need to be overcome for this. Claire, would you like to give some insights from Photorama?
Okay, yeah. Technical challenge, yeah. This is a huge challenge to recycle those valuable and critical materials. As I've mentioned, the current practice doesn't allow it. We have two challenges. First, this is to separate all the components without mixing them, and this way we can recover high purity materials. So you know how is PV panels. The first step is to remove the external component, preferably without breaking the glass sheet, which is quite challenging. So we remove the frame, we remove the junction box. So that's the first step. The second step is to open the sandwich, separate all the layer. So we have the glass sheets, the polymer, the solar cells, and the backsheet. The idea, again, is to separate them without mixing them as much as possible. And I would say this is quite a big challenge also. We need R&D. We need more investment in R&D, because we have technology today, but we don't have enough, and we are not ready also for this step. And I would say that the last challenge is the recovery of the metals, because again, we know that the technologies that are used to recover metals are not very environmentally friendly. And this is also technology in Photorama that we try to we develop it, and this is based on green solvent, and we try to make it environmentally friendly to also overcome this challenge. And I would say the main challenge is to make a business case. So we have to be smarter than others, and we have to work very hard to make a strong business model. But I think we also need the support of the PV industry to take part in this, to support by, for example, buying the secondary raw materials as a mark of, as incentivize on the sustainability of their product. That could be something.
Great, thank you. Any last words from our panelists? Otherwise, I'll take this moment to conclude. One, thank you for these words. And thank you for all of your insights. I mean, as we can see, this is a very complicated topic, coming from the legislation side, from the business, financial side, as well as the technological side, dealing with the sustainability of the PV cycle of the PV sector is going to be one of the biggest challenges in the coming decades. But I like Claire's words from her speech and saying that we've actually come a long way. So let's not forget all of the progress that we've made so far. But yeah, the job's not done yet. And I thank you guys for joining us today, and thank you for submitting your questions and taking part in our quiz. I'm still very impressed by your knowledge. Our panelist will be around in the coffee break if you want to have a chat with him. And otherwise, I wish you a lovely day at the EU Sustainable Energy Week. Thanks for joining.